Okay, this is part 253. Line 2211, 3 Nucleon force fuels alpha Decay Meson Neutrino 4 Quarks 5G Wow Seti. This is a series of 5 videos, and I'm going to try to show you how to take your neutrinos and split them into 4 quarks. I don't know if it'll work. It's based on the formulas and ideas that come from the data. It did give me an idea of how to try it, and other people have actually made it split into quarks, so since a neutrino mimics other particles, I thought we would try it, okay? But it's 5 videos. It's going to be line 22E11, then line 22E12A, 12B, 12C, and 12D, okay? And I'm filming this July the 8th, 2012, and the research was done June 24th. So this is the Wow Seti alien radio signal here, with the equation and the numbers that come with it. And when you Google the numbers, this is the type of data that comes up with it. So we've got a new equation now. We're on line 22, okay? So we're going to Google 3 nucleon system, and it's quotes from Wiki. Is a 3-body force is a force that does not exist in a system of 2 objects, appears in a 3-body system. In general, if the behavior of a system of more than 2 objects cannot be described by the 2-body interactions between all possible pairs as a first approximation, the deviation is mainly due to a 3-body force. And there's a diagram of a PNN, and that's the 3-body force. A conjectural example of an interaction between 2 neutrons and a proton. The triton, or hydrogen 3, which is beta unstable. An example of a stable 3-body interaction would be between 2 protons and 1 neutron, the helium-3 isotope. I'm going to Google alpha particle helium nucleus. Alpha particles, named after and denoted by the first letter in the Greek alphabet A, consist of 2 protons and 2 neutrons, bound together into a particle identical to a helium nucleus, which is classically produced in the process of alpha decay, but may be produced also in other ways and given the same name. The symbol for the alpha particle is A, or A, that one there, and it can be written as He2 plus 4 to He2 plus or 4 2EHE, as it is possible that the ion gains electrons from the environment. Also, electrons are not important in nuclear chemistry. The key words in quotes from Wiki are alpha particles plus 2 protons plus 2 neutrons bound plus helium nucleus plus alpha decay plus ion plus electrons plus high velocity helium nuclei. Here's alpha decay here. And of course we've seen this several times in the videos, right? This is the composition of 2 protons and 2 neutrons. The statistics are bosonic, and there's the symbols, and there's the mass, and blah, 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 okay? It's got an electric charge of 2e. Next is the 3 generations of matter, the fermions. We've seen this at the very beginning of the series of videos. Back in the 100s, this came up. Actually, at the very beginning, it came up. So it has quarks, leptons, gauge bosons, mass, charge, spin, and name, okay? So, quote from Wiki. The standard model for elementary particles with the gauge bosons in the last column. In particle physics, bosons are one of the 2 fundamental classes of subatomic particles, the other being fermions. Bosons are characterized by their obedience to Bose-Einstein statistics. This class of particles includes photons and gluons, as well as the hypothetical Higgs boson. The 26th of June 2012. My thoughts. Bosons and fermions come up at the beginning of all the videos, along with photons, gluons, Higgs boson, and subatomic particle formula ideas. Quote from Wiki. Alpha decay, a higher energy version of alphas than produced in alpha decay, is a common product of an uncommon nuclear fission, result called ternary fission. However, helium nuclei produced by particle accelerators, cyclotrons, synchrotrons, and the like, are less likely to be referred to as alpha particles. Alpha particles, like helium nuclei, have a net spin of 0. Due to the mechanism of their production in classical alpha radioactive decay, alpha particles classically have a kinetic energy of about 5 MeV, and a velocity in the vicinity of 5% the speed of light. See discussion below for the limits of these figures in alpha decay. They are a highly ionizing form of particle radiation, and when resulting from radioactive alpha decay, have low penetration depth. They are able to be stopped by a few centimeters of air or by the skin. However, so-called long-range alpha particles from ternary fission are 3 times as energetic and penetrate 3 times as far. Alpha decay. An alpha decay is a type of radioactive decay in which an atomic nucleus emits an alpha particle, 2 protons and 2 neutrons, and thereby transforms or decays into an atom with a mass number 4 less an atomic number 2. For example, 238, 92U to 234, 9DTH plus 4, 2HE, which also became written as 238U to 234TH plus A underlined. Okay? Since an alpha particle is the same as a helium-4 nucleus, which has a mass number 4 and atomic number 2, it also has a charge plus 2. But the charge is usually not written in nuclear equations, which describes nuclear reactions without considering the electrons. This convention is not meant to imply that the nuclei necessarily occur in neutral atoms. Alpha decay is by far the most common form of cluster decay, where the parent atom ejects a defined daughter collection of nucleons, leaving another defined product behind. In nuclear fission, a number of different pairs of daughters of approximately equal size are formed. Alpha decay is the most likely cluster decay because of the combined extremely high binding energy and relatively small mass of the helium-4 product nucleus, the alpha particle. Alpha decay, like other cluster decays, is fundamentally a quantum tunneling process. Unlike beta decay, alpha decay is governed by the interplay between the nuclear force and the electromagnetic force. Alpha decay typically occurs in the heaviest nuclides. In theory, it can occur only in nuclei somewhere heavier than nickel element 28, where overall binding energy per nucleon is no longer a minimum, and the nuclides are therefore unstable towards spontaneous fission type processes. In practice, this mode of decay has only been observed in nuclides considerably heavier than nickel, with the lightest known alpha emitter being the lightest isotopes, mass numbers of 106 to 110, or beryllium element 52. Alpha particles have a typical kinetic energy of 5 MeV, that is this thing here, of their total energy is that, and a speed of that. This corresponds to a speed of around 0.05 c. There is surprisingly small variation around this energy due to the heavy dependence of the half-life of this process on the energy produced, the equations in the Geiger-Nudel law. Because of their relatively large mass, the +2 electric charge, and relatively low velocity, alpha particles are very likely to interact with other atoms and lose their energy. So their forward motion is effectively stopped within a few centimeters of air. Most of the helium produced on Earth, approximately 99% of it, is the result of the alpha decay of underground deposits of minerals containing uranium and thorium. The helium is brought to the surface as a byproduct of natural gas production. Composite particles such as hadrons, nuclei, and atoms can be bosons or fermions depending on their constituents. More precisely, because of the relation between spin and statistics, a particle containing an even number of fermions is a boson since it has integer spin. Examples include the following: any meson, since mesons contain 1 quark and 1 antiquark. The nucleus, or a carbon-12 atom, which contains 6 protons and 6 neutrons. The helium-4 atom consists of 2 protons, 2 neutrons, and 2 electrons. The number of bosons within a composite particle made up of simple particles bound with a potential has no effect on whether it is a boson or a fermion. Fermionic or bosonic behavior of a composite particle or system is only seen at large compared to size of the system distance. At proximity, where spatial structure begins to be important, a composite particle or system behaves according to its constituent makeup. For example, 2 atoms of helium-4 cannot share the same space if it is comparable in size to that of the inner structure of the helium atom itself. So there's the equation there. Despite bosonic properties of the helium-4 atoms, thus liquid helium has finite density comparable to the density of ordinary liquid matter. That was a bunch of data, and now we'll look and see what we get from this data, okay? So this is June 26, 2012, my thoughts. Line 21 and 22 talk about helium-3 and 4 in the fuel formula ideas from keywords And here it comes up with alpha particles, and it mentions nuclear fission. I was trying to come up with a formula so you can split a neutrino into 4 quarks. I see this composite particle, any meson, since mesons contain 1 quark and 1 antiquark. Try colliding coated neutrinos with baby mineral oil from Janet Conrad's experiments. Those are in earlier videos. I think it's in line 20 or 19. She shows up with this meson that contains 1 quark and 1 antiquark. The neutrino replicates other particles. How do you collide a meson into 4 quarks? Google to see if anyone's done it. So that's what I've done. I've got a formula and idea for CERN to try on, or Janet Conrad. Maybe she wants to try it. There are 5 videos altogether, one on line 22E11 and 4 videos on line 22E12. Video parts 1 to 4 are listed as A to D. For my formula ideas along with the data, I want you to try this and blog your results. The Idea Girl says, thank you for helping me prove these theories. Okay, so the next videos are going to be called line 22E11, 3 Nucleon force fuels alpha decay meson neutrinos 4 quarks 5G Wow Seti. And then line 22E12 is going to go A, how to collide neutrinos and create 4 quarks UFO 5G Wow Seti. And of course I've just added A, there's A, then there's B, C, D to the same title. Okay, so you'll be able to find them. I'm going to blog all of them together, and when I put them up on the website, Victoria Stafford, a Second Investigation, you'll be able to see all the research notes and everything to work with, okay? So I'm going to be uploading all of these together, hopefully.